Okay, I'm Arenity, and we're explaining the retrosynthesis of this reaction, so how we are starting working backwards from this molecule to get to that molecule. And we're starting with two synthons that we made, and we split the molecule between this bond, at this bond, and we assigned the positive charge on this carbon and the negative charge on this carbon, because here this carbonyl acts as an electron withdrawing group by induction, and so this carbon would be partially positive, and so it makes more sense that this carbon would be positive and this would be negative. And so, what was the word you used to that?
Oh, we're just finding its synthetic equivalent.
Yeah, we're finding the synthetic equivalents of each of these synthons, and for this one, we're working backwards and we're adding a hydrogen onto this oxygen and getting rid of the double bond, and then again getting rid of this hydrogen and the positive charge and creating an epoxide ring.
Okay, so I'm starting with this and I want to find its synthetic equivalent. And then I go to the Grignard reagent. Then I go to without the magnesium attached. And then finally we arrive at our synthetic equivalent.
Hi everybody, my name is Emilio, and the way that we decided to go on our synthesis problem was to use this group because in the next step we are using it because it is a bulky protecting group and it will be attaching onto a primary alcohol into this step.
Okay, I'm Riley. I'm going to be explaining this step. So we start with this molecule here with a bulky protecting group here. Then, as a sequential step, we add 9-BBN followed by sodium peroxide and, sodium hydroxide and peroxide. This attaches the alcohol on the third position. This is because this acts as a bulky protecting group, making 2 more sterically hindered than 3. Therefore, the alcohol attaches at the third carbon.
Hey guys, it's Tyler. This here is where we're at in our synthesis. The next step is going to be a nucleophilic substitution in which the hydroxyl group will be removed and replaced with the Br group. So what will happen is that the HBr will break down and the bond will break. This hydrogen will protonate the OH group. This will create water. Water will act as a leaving group. And then the Br will come in and do the backside attack. And it will create this molecule here.
Okay, I'm Sai. And for my step, I'm going to start by adding RMG to make a Grignard reagent. So it's going to look like this. MgBr. And then from there, we add the epoxide. And the Grignard reagent will attack the epoxide right here, which will give us something like this without the hydrogen. So we do our third step, and we add the H3O+, and that gives the hydrogen, and then you're there.
My name's Kyle, and starting from this point, we will use TBAF to get rid of the protecting group down here and get to this point. And then using Jones oxidation, we will get our target molecule, where at the primary alcohol, we will get carboxylic acid, and then at the secondary alcohol, we'll get a ketone.